So this is Pong on suspenders. These suspenders are LED strips. I have a pressure plate and a button here. The button actually changes modes, but does a bunch of different things. The pressure plate starts the game, and things go down. And I press the button, press the resistor, press the button. They go back and forth, and back and forth, until somebody loses. And that's the game. And there's Pong on suspenders. So here I have the Pong-playing suspenders. So ultimately these have three modes. The first mode is Pong. So I have a pressure sensor here, which will probably ignite by me touching it. I've got a button over here. So this is what starts each animation, and this is what changes the animation. While you're playing Pong, then this will act as your standard button, so I'll just get that started. So the Pong ball will go down there. In this case, this side lost. So I'll press that and bounce, bounce, bounce. Now this will get faster every time. I won't play a full round because I'll probably get pretty quick, and boom, that side lost, that side won. Simple enough. If I press the button, it changes the mode. So now I'm in pressure mode. So depending on how hard I press, that's how much you're going to get. Change the mode. I got sparkly mode. There's rainbow mode. Then we loop back to Pong. Now I'm going to show you the wiring, and then we'll get into the code. So before getting into the wiring, I want to talk a little bit about assembly. Now, I tried to use hot glue, but as you can see here, the hot glue sticks really well to the fabric, did not stick terribly well to the NeoPixel strip. So here for my button, I have two wires coming out, and then I have them hot glued. I have them hot glued into the back. And essentially exactly the same thing. And exactly the same thing for the pressure sensor. Here I've got the two leads. I've got two wires that are hot glued and connected into the back. So all the wires lead here into this Circuit Playground Express. So I bought 100 pack of these spade clips. And these spade clips are perfect because you can just pinch them down with a wire crimper or whatever else, and then they become perfect screw-on terminals. So that's what I've done with all of my wires here. And I have color-coded my wires, but it's pretty simple. I have common ground going anywhere the ground needs to be. I have my 3.3 volt power, so I actually have multiple wires coming into here for that, multiple wires coming into the ground. So this is a little loose, so I will probably screw that in. And I can screw in, and I just have nuts. I just have bolts on the bottom holding that in. I have a pretty beefy LiPo battery there. You could probably run this off a significantly smaller battery, but I wanted something big because I did not want to run out of it while I was, showing it and demonstrating it. I have a large resistor going from my A1 to my ground, and that is just because when you have a button, you want to have that as an option. To prevent against shorting, and everything else is wired up here. So the NeoPixel strip, each one, these are 50/50s. I'll have a full link to buy these exact ones, but pretty much any 5-volt NeoPixel strip will work. This is running off of 3.3 volts, and I found that most NeoPixel strips will work off of 3.3 volts. Higher quality strips will work a lot better. Lower quality strips, you never know. So other great thing about them is that they only need 3 wires. They need power, they need ground, and then a signal. So I'll have, for each of them, I have 1 signal wire and then power ground, and then I just need the 2 buttons. So I have minimal usage of the actual terminals themselves, so I even have room, like if I want to do 1 or 2 more, I could use A4 and A3. But when it comes to the build, this is pretty much it. So you have, it's a little hard to see there, but you have the resistor. I believe mine is a 10 kilo ohm resistor. Something is short circuit protection. There's a lot of information out there, and I am by no means an expert and can't really explain that. You could use the NeoPixels on here as well. Other than that, that's the 2-button setup. That's the wiring setup. And I will walk through the code, and that will make things a little bit more clear as to where things need to be plugged in. So here I have the code. I will put a link in the description to this exact code file on GitHub, so you can just copy and paste it and use it. But I'm just going to do a quick walkthrough. I do want to point out that a lot of this code was from the Adafruit NeoPixel strip test library. It had some basic animations that were just really neat and useful, and if it's already been built, why rebuild it? So some of this is very common and a lot of it is used, and I do my very best to note where it was taken from that library to provide them both credit and to let you know where you can look if you want to find additional items. So the button is connected to A1 and 3.3 volts, and it's also connected through a 10 kilo ohm, I believe, resistor. The actual size of the resistor doesn't matter. It's more just to protect against shorting. So I set my number of pixels with 72. So that means I have 72 pixels per side. So it's a total of 144 pixels, if I can math correctly. So each strip is identical in this case. If you use a lower density LEDs, then you would just want to change the number of pixels you have. I used WS2812B 5050 RGB LEDs. I did get these. I must admit, these ones were from a Chinese website, Banggood. The quality from there has been really great, and the price was super great. The Adafruit NeoPixels are much pricier, but they are of much, much higher quality. So if price is not a problem, I would say go with the Adafruit ones, and if you want to do these cheaply, I would say go with Banggood. I will have links to buy both of those. I will also have links below for Adafruit's NeoPixels with a diffuser on top, and the diffuser will probably hot glue really super well. But I'll leave you to figure out the best way to get the pixels onto the suspenders themselves. So here I define an array of 2 different Adafruit NeoPixel strips. So it's a strip with an array size of 2, and I set connection to A2 and A5. So both of my NeoPixels are connected to power, ground, A2, and then A5. So I have a Boolean active animation. I believe this is unnecessary, but I'm not really going to remove it at this point. I have a Boolean for left button being pressed and right button being pressed. I have my button state, my mode, and my button weight. So I'm just kind of declaring some variables that I'll be using. I have the basic setup. I've left in some basic items and code from the strip library that is not necessary, especially if you're using the Circuit Playground Express, but I have it in here in case you decide to do this on a different board. So my serial start, you can ignore that or comment it on if you want. The Circuit Playground begin, I am not using too much of the actual Circuit Playground, so if you use a different board, you can comment this out. And maybe 1 or 2 other lines of code that I was using more for testing. So with the NeoPixels, you have to start by strip.begin, set brightness. So I set the brightness to 10. So what you're seeing is about 5% brightness. The total brightness can go up to 255. So I picked 10 for a few different reasons. 1, I didn't want to blind people. 2, it's pretty low power. The lower you set your brightness, the lower the power is, which means the longer it's going to work. So if you want to be bright and you want to stand out in broad daylight, you can up this to 150 or 255. And then .show initializes and sets all the pixels. So in this case, I'm initializing both strip 1 and 2 and setting my pin mode for my button to input. I have an animation function, fill from the bottom, which does exactly what it sounds like. It fills pixels starting from the bottom one and works its way up. You can read through, in most cases, I've added comments that explain how everything works. I'm not going to go through in detail how all of this works, but I'll go through this one first. So the way you address a pixel is you do a strip, and then in this case, since it's an array, you have the ID of the array, so in this case, J. Set pixel color, the number of the pixel, and then the color you want. So you can actually probably just get away with saying parentheses 0, 200, 0. But in this case, I am using the color function, which will make sure it gives it the raw color. All of these are RGB. So I have the star animation. So the star animation is not actually active in the strip anymore. This was a really, really slow blink, basically. It would pick one pixel, fade in and fade out. Because I wrote the code, I left it in here, but this code is not actually executed. So you would have to initiate this later on if you wanted to see this. So the glitter animation was what you saw when the lights were kind of flickering on and off very, very quickly. And this loops 100 times, and it loops through each pixel and gives it a random value of 1 to 6. And if it's 1, set it to white, otherwise set it to black. So what that means is that 1 out of every 6 pixels will light up, and that will just constantly change. So that randomness kind of gives it that sparkly flash. And I have a delay of 50 milliseconds between each animation, which basically means the pixel's on for 50 seconds, and then it wipes everything, and then turns the new ones on for 50 milliseconds. This is, if you make this quicker, then it'll happen quicker. If you make it larger, it'll happen slower. Then I have a function reset strips, which sets everything back to completely black. We have Pong. Pong starts by resetting the strips, notes that the game is on, and then I set my initial variables, winner, loser, ball direction, which says is the ball going one way or the ball going the other. I have a game delay. The game delay is how much time is going to happen between each loop. If you're doing this on a slower processor, so like let's say you're running on a really old Arduino Mini or something like that, you might want a slower delay to start. If you're on a much faster chip than the Circuit Playground Express, so let's say you've got a new Cortex M4 Plus or something, and it's super fast, you might want the game delay to be faster. Otherwise, the ball and the animation will happen just way too quickly. So you can tweak this. So this number will go down every time that the ball is bounced back, and that makes the game go faster. The ball gets a random start direction. It either starts in +1 or -1. So that determines if it's going down the right side or down the left side. So then we have the game loop. So while the game is on, basically run through some simple animations. The simple animation sets a line, and that line is where you need to hit the ball. And then I have the previous ball position, and then we move the ball. So you want to take the previous position, set it to black, and the new position, and set it to white. And that's what this is. Then we want to show. Then we want to delay. So assuming that we have a delay, do a delay. Then we check to see whether or not the ball was hit. So there is a 4-pixel window on each side that the ball could have been hit. So if it was hit, change the direction and then reduce the game delay. So we check on the left side and we check on the right side. Then we check for the win condition of one player. And we check to see if basically the ball position is off of the NeoPixel strip. If it's off the first one, then the winner is player 1. Otherwise, the winner is player 0. And that will also break the loop. So we say game on is false. So once the loop is broken, then we show the winner is red, green, blue. So it's green. And the loser is red, green, blue. So 255-0-0. And this is going to be red. So the winner is green. The loser is red. Then we show both strips and we give 3 seconds. So the winner loser displays for 3 seconds and then everything resets. Reset strip just fills with 0, 0, 0. So basically make everything black and then show everything. So then we have the main loop. So the main loop is ultimately what is constantly running, except when there's an animation. So we check if the left or right button is pressed, and this is the Circuit Playground left and right button. This is not necessary, so if you're not using a Circuit Playground, you can totally get rid of this. This was mainly used for me debugging before I had installed my buttons, just to make sure that buttons worked and I could play animations on command. If the left button is pressed, run rainbow, and if the right button is pressed, run rainbow, basically on the different strips. So all this set of code and this set of code is unnecessary and can be removed if you're not doing a Circuit Playground Express or you just don't want it there. So then we have a button wait. The problem with buttons, especially when you're programming in Arduino, is when you press that button, it is constantly being pressed. So your code of, hey, is this pressed, is going to run over and over and over and over and over again. So what I want is register that first press and then ignore input for a certain amount of time. So in this case, I'm ignoring it for about 1,000 loops. And 1,000 loops could be any amount of time, depending on what is actually being processed. I have found that when nothing's running, 1,000 loops tended to be about 3 or 4 seconds. If you're running this again on a slower thing, then 1,000 might be too much. You might need to make it like 200. If you're running this on a faster processor, 1,000 might be too fast. I decided to stop the increment of button weight because I didn't want this to overflow. So I figure if the number's 10,000, then yeah, you're all good. So if you press the button, so this is the button, not the pressure sensor. So if you press the button, it changes the mode. So it'll give mode ++. And if our mode is greater than 3, set it equal to 0. So this basically makes it a loop. So mode 0, mode 1, mode 2, and then if you hit mode 3, that's great, and then it goes back to mode 0. So the next is we need to read the resistor. So resistor is analog A6. So this is going from 3.3 volt to A6, and this is measuring the resistance. And my multiplier is going to be used for the pressure sensor. So on that pressure mode, what I want to do is basically convert the signal. So when you press down really hard, the maximum value you're going to get is 1024, and the minimum value you're going to get is about 50, because we are having a resistance gate. So we're ignoring the first 50 ohms of resistance from this, so that just blowing on it doesn't set it off. So depending on what mode you're in, if the resistance is greater than 50, then we are going to execute whatever that animation is. So it's either start playing Pong, it's going to fill it from the bottom, it's going to play a glitter animation, or it's going to play the rainbow. So you're using the button to change the modes, and you're using the pressure sensor to trigger the animation of that mode. Below is a bunch of functions that were copied directly from the Adafruit strip, from the Adafruit NeoPixel library. So I'm not going to walk through that code because first off, it's not my code. And second off, it is freely available through Adafruit. But I do want to give them a huge shout out, and we'll link to their GitHub as well into the comments. And that is the Pong-playing suspenders. If you end up making these yourself, please make a video or take a picture and post it below. I would love to see what you do. I'd love to see if you change anything, if you make a different game or you add different interactivity elements to your suspenders, or you put it on a hat or something else. I would love to see what you do with this code, and hopefully this has helped you. And thank you so much. And if you like this video, please like, subscribe, and comment all that wonderful jazz. And I will talk to you soon. Bye.